Yeah, I also want to say some of my kids could hear what you were saying.
Oh, yeah.
So I just want to make sure we understand the whole safety thing. Mr. Corbett and I have been in each other's little bubble or pod since March. So that's why we're not wearing masks together, because we've been very, very careful. We're like family. So his family and my family, we've been spending time together, going camping in the summer. And so that's why we're able to do this from his kitchen. Now, my student teacher, Miss Seaman, that you can see over there, that's why she's not here, because she has not been in our bubble. So she's staying safe where she is, and we're able to do this together.
Well, speaking of safety, Miss
Yes.
Hannigan, we want to make sure you guys know that we're safe here today. And so here I have a fire extinguisher, and this is in the case that any of our experiments go awry. We have a fire extinguisher that is full. It is green, so it is good to use. So that's one base that we have covered.
Mm-hmm. Yep.
Now
we have.
Oh, what's that,
My
Miss Annie?
blankie.
Oh, what is that for?
Well, this is because we are going to be doing things with fire, supposedly, right? And so if Mr. Corbett catches on fire, I just do this, and it puts the fire out.
Yeah, this is a flame-resistant blanket that will smother a fire. So we have our bases covered with the fire. But guys, we are still missing something here. Take a look at Miss Lanigan. This is our final show, and I thought that you would have figured it out by now. She hasn't figured it out, guys. What is Miss Lanigan missing right now for lab safety? What do you guys think?
Marvin.
Face mask.
Oh.
Boom.
I don't have
Face
a mask.
protection.
This is good.
Oh. And I see that. I am so sorry if I mispronounced your name.
Oh, but hey, Morgan. Yeah, there you go.
Please correct me if I mispronounce your name, okay?
Side. Side.
She's not wearing that what you're wearing.
I have this. This is like the same idea.
What if I had a fire right here?
One big thing. Oh, like, sorry, can I add on to yours? Yeah, sure. Her hair is long, so it's very vulnerable to fire.
Boom.
That's what I forgot.
That's what we're looking at. Miss Lanigan,
Okay.
That's going to be trouble.
And then, you could put, some of those, and it also is very, because the fire can also spread, and it's also vulnerable to chemicals that can stain it.
That's right. So, we've got the hair up now. I think we are ready to start, Miss Lanigan. Now, my sixth period here. Do you guys remember that science word I made up? Do you remember the word I made up? And it was an adjective to describe a weather. Does anybody remember that? Anybody remember that? No? How about precipitatious? You guys remember precipitatious? It's very precipitatious today. That's an adjective to describe rain. Well, me and Miss Lanigan had a meeting where we interviewed Kiro 7's weatherman, and he agreed that that was going to become a word. So you guys did witness the creation of a word. Miss Lanigan, you owe me $1. Because I bet Miss Lanigan, Miss Lanigan, if precipitatious is a word, you're going to have to owe me $1. Will you owe me $1? Can I have $1, please? Oh. I don't want dirty money, Miss Lanigan. Can you guys believe that? She's handing me dirty money. I never like dirty money.
I'm a sore loser.
Here we go. Here's what we're going to do. And remember, don't unmute yourself. Use that hand-raised button. Thank you. So that is gross, Miss Lanigan. Okay? So in order for that, I'm going to go ahead and try something out to fix this. So for this, I'm going to clean this dollar bill because I only want a clean dollar bill. So now for this, I'm going to take this right here, okay, little glass container. I'm going to put it in it. Now, if you ever got a shot, they're going to wipe your arm with a piece of cotton that was attached to rubbing alcohol. Rubbing alcohol kills just about everything. And this is a special solution. So I'm going to use it to clean this dollar bill. Okay, there we go. Now we're talking
Now we got
clean.
wet money.
There we go. Okay, got to get this really good because I like my money clean. Okay, so there's still, now it's really wet. So Miss Lanigan, okay, what I want you to do now is I want you to kind of just hold this up out like that, okay?
Okay, so we're gonna let it dry.
Okay. Yep, so we're gonna watch it dry. Well, you know what? You know what else really sanitizes things is fire. So let's go ahead and
Wait, what? What do you, what? Why?
Oh, yeah.
Why?
Okay, there we go. Now my dollar bill is nice and clean. Perfect. Oh, look at that. Now I can take it. Thanks, Miss Lanigan.
Wait a minute, I need to see that. I want to see, what are you talking about? It's,
Mr. Corbett?
It's clean. It's clean in there.
Isn't it just on fire?
So guys, remember, use that hand raise button. So it is good in there. So guys, think about what we've been learning. Why did that dollar bill not burn? And use the hand raise button, and Miss Seaman is going to call on you.
Yes, Nerman.
I think it's with the alcohol, something with the alcohol.
Nerman says it has something to do with the alcohol. Nerman, you are on the right direction.
All right. I see Sire from your class, Mr. Corbett. Every time I unmute that one, it gets weird, so I have to just talk from this
Here,
one. I'm sorry.
I'll go. Hey, Sai, what do you think?
I think that's because, I think it's actually because, wait one second. I think it's because you put rubbing alcohol inside the, on the dollar bill, and maybe rubbing alcohol has special properties. You just put normal money inside it, that fire will burn it. But since you put rubbing alcohol on it, maybe some rubbing alcohol has resistance to fire, and you just said it can kill about anything.
wait, let me see that bottle.
You are on to something, Sai.
I noticed something on the bottle. It says 70% alcohol. What's the other 30% in there, do you think? Chocolate milk?
What do you guys think? What's the rest of that 30% in there? What do you think in there?
It says you're muted now.
I'm so sorry, Mr. Corbett. I accidentally muted you on yours.
So what do you guys think that extra part in there is?
Did unmute. I'm sorry. Seth, what do you think?
Water.
Water. It is water. So in here we have water. Now, what would the water have to do with this dollar bill not burning? What do you guys think? What do you think out there?
Elise.
Well, water puts out fire.
Water puts out fire.
Okay.
Let's see.
I see.
Who else in my class? Who else thinks they knows what's going on in here? I want to hear for some more people out there. What do you think the water had to do with?
Corbin.
Water is non-flammable.
Water is non-flammable. What else?
Okay. Marvin.
The water cools down the fire.
Water cools down the fire.
Hey, can we?
How about somebody from Corbett's class? What else do you guys think on there?
Sire
What was
raising
that,
her.
Evaporation.
Evaporation. We're getting along the right way. We're getting closer, guys. We're getting closer.
So many hands up.
How about you, Mom?
Nerman.
Since there was part of it was water, the fire caught on the alcohol, not the paper. And since part of it was water, it only burned for a little bit, and then it extinguished it. And the reason, and it burned, and the fire burned away the alcohol and the fire. And
Nerman,
You got it.
You have got scientific poetry coming out of your mouth right now. You nailed it. Nice job, Nerman. Let's everyone give Nerman round of applause, Nerman. Round of applause. There we go. Nice. Now, Nerman said, hey, look, that water is absorbing some of that heat. Now, when we think about weather and what we just covered, right, we talked about ocean currents moving a lot of heat around the earth, affecting weather. Well, water can hold a lot of energy. And so that alcohol also was less dense than the water. If you think back to the density lab, remember the alcohol sat on top. And so when this was soaked in a water alcohol solution, that alcohol went to the top and went burned, and the water protected the dollar bill from burning. And that is what we had protecting the dollar bill.
So the two liquid densities are different. They didn't mix. The alcohol is less dense. So when we had it in the test tube and it rose to the top and the syrup sunk to the bottom, that's what's going on there.
Money! All right, Miss Lanigan, here we go. Are you ready for your next challenge?
I am ready. Let's do it.
Okay, now this is a tough one, Miss Lanigan. Okay, here's what I need you to do. I need you to go ahead and light these two candles in here. And I'm going to go ahead and go open up this back door.
Oh, yes, and I closed a window here. It's really cold in here. So before you, we had a little, it's not lighting.
You can do it, Miss Lanigan.
It wasn't an accident. We had all the fire smoke detectors go off in Mr. Corbett's house here because we had too much fire.
Nice job, Miss Lanigan. Round of applause for Miss Lanigan. She just lit the two candles. That concludes the extravaganza.
See ya.
We're just joking.
No, come back.
Miss Lanigan, here's what I want you to do.
Yes.
Step to the back here. And I want you to try to blow those candles out just with your mouth. Just try to blow them. You can do it. Oh, you were so close, Miss Lanigan. Okay, give it one more shot. Oh, okay. Now, I'm going to give
This
Miss
is
Lanigan,
why old people don't have birthday parties.
I'm going to give Miss Lanigan something that you guys could try at home, okay? Now, everything else we are doing, you should not try at home. We are trained professionals, and this is everything we're doing on here you should not do at home. But this one right here is something that you could do. So this is a bottle, and this bottle has the bottom cut off with a balloon attached to it. So, Miss Lanigan, can you now try to use this, and you want to pull from the center and aim it at the candles and try to put the candles out from where you were standing. You can do it. Miss Lanigan! Oh, you were so close. One try. Oh, two.
What's going on?
Oh, 3 tries. Miss Lanigan?
Yes.
I bet you for that dollar again that I can do it in less. You did it. Wait, you did it in 3 times?
3 times.
Okay, how many people think I can do it in 2 times or less? Come on, let me hear. Let me hear some hands. Let me see some hands. There we go. Okay, all right. So I got some people. Okay. All right. Here we go. Here we go. Here it comes. I got to get ready. Well, let me stretch. Okay. Here we go.
I quit.
Oh, I like it. Why were we able to blow the candles out from so far with the bottle, but Miss Lanigan couldn't blow it out? What do you guys think?
I couldn't hear anything you just said because someone was clapping.
How were we able to use this to blow the candles out, but I couldn't blow it out just by blowing on it?
Ooh. I see. Yana, what do you think?
I think that the balloon sort of melted a little bit when it was held over the fire, the flame, and so that it starts to, like, there's a small amount of smoke coming out, and so then it starts to push onto the melted part of the balloon, and then it pops.
Okay, awesome, great thought.
And I see Ryan from Mr. Corbett's class put in the chat because of the airflow.
Hey, Ryan, tell us more about that.
And then
so when I shot the bottle cap, a bunch of air came because so there was a bunch of air with the force of coming with the bottle cap. So then the air took out the fire, and that's why it went out.
Ryan, that was scientific poetry as well. That air, when we pull it, we're missing one other piece in there. Let's see if we have one more person here from Miss Lanigan's class who thinks that they might be able to fill in that piece.
Hint, think what Mother Nature hates.
Soren?
I think it's just sending puffs of smoke that don't have enough oxygen for the fire to keep going.
Okay.
And then it puts it out.
Interesting. Let it go, Miss Lanigan. Oh! Now, when we pull this back, what is that creating? What's it creating? That's creating empty space, right? Empty space. and the air goes into it. And just like Ryan said, whoa, it's creating a force coming out of that bottle. So we're concentrating the air, and it is shooting it out of the bottle through that small port. So this is kind of fun. You can put little pieces of sponge, as you guys saw in there, and wet, and we can use this. But this is how we blow out candles, because blowing out candles with blowing air, that's so 19th century, guys. That's not the new stuff.
That's 20th century.
20th century. So here we go. Okay, Miss Lanigan.
Yes, sir.
Are you ready for the next attempt here? Okay.
Sure.
So let's go ahead, and before we start this one,
we should probably get that going. Huh?
Let's get this thing going. So guys, right here is a hot plate, okay? And a hot plate is going to get really hot. I'm going to turn it up to 10, and I'm going to put it about right here. That way you can see. We're not going to use this quite yet. It's going to be, we're going to come back to it. So I'm going to take some water. Now this can right here is just a sparkling water can, and it's pretty much empty, right? There's like some little bit of water left in there, but it's pretty much empty. I'm going to add about a tablespoon of water into it. Okay, that's about maybe a half tablespoon, and we're going to set it on this hot plate. And I want you guys just to watch it in the corner because as this thing starts to steam, let us know, and we're going to come back to that, okay? So, for the next one.
Lots of steam.
Okay, can you light that candle again, Miss Lanigan?
Yeah, of course I can.
Okay, good. All right. Now, this is a very special balloon. It was given to me by Professor Dumbledore himself. So I need you to take special care of this balloon. Can I trust you?
Of course.
Okay. All right. So here we go.
That's talent.
Okay. All right. Good. Okay. So we got a balloon here.
Yeah.
Okay. Now I want you to take this balloon and I want you to hold it over the candle about an inch above it. All right.
Wait a minute, but
you can do it.
This
You
is
have
a
the
special
power.
balloon.
You have the power. It's not. It's going to be okay.
Okay.
Just don't break my balloon. It's very special.
Okay. So this is about an inch, right?
Is that an inch?
Is this good? This is good, right?
Not an inch.
Oh.
No.
Okay, so say
Closer.
when. Just say when it's an inch. That's not an inch yet?
Closer. It's an inch. It's an inch.
Oh no! My balloon! I'm so
You
sorry.
told me to do it.
I'm so sorry. Okay, Miss Lanigan, it's my fault. It's my fault, guys. I did not give Miss Lanigan the power. Okay, can you relight it? I'm gonna give you the power.
Oh God.
Okay, I'm sorry. It's my bad. My bad. I'm sorry. I'm not bad. It's okay. Okay, now I'm gonna give you the power. Are you ready?
Yeah, I'm ready.
Oh yeah.
Oh.
You got it?
I like that.
You got it?
Yeah.
Okay, she's got it.
I have
Okay.
it. I
All right.
feel it.
Okay, I'm gonna blow up another balloon here.
Okay.
Okay. So
I'm
here
excited. I'm excited. I got the power.
we go. Okay. All right. So I want you to hold this balloon now and try to get. Now that you have the power, hold it above that candle, and here we go.
1 inch.
1 inch. You can do it.
Isn't that an inch yet?
Is that an inch?
No.
All right. Let's do it.
Say when. Say when. Say when.
Now.
Is that an inch?
Yeah.
Yeah, that's good.
A little lower.
She has.
Lower. Lower.
She's got the power.
Virtual hand, please.
It's the power of Dwight Schrute.
Why is that balloon? What do you
Dwight
guys think?
Schrute,
Why is the
that's
balloon not
amazing.
popping?
I think I know why.
Why?
It's a ball.
Is there water in the balloon?
Hear it?
I heard somebody say something about water in a balloon, and that answer is
Water balloon.
there is water in the balloon. Now, why having a little bit of water in the balloon? Why would that make this balloon not pop?
It cools it down.
Like the last one.
Close.
Corbin, what do you think?
Sorry, that was for my last one.
Oh, okay. Nerman, what do you think?
I think it cools it down from since the heat is heating it up, but the water is cooling it down, so it does. So and since heat makes things, since heat is less dense, if you heat something, it will become less dense, and that's why it popped. And since there's, I'm guessing, cold water, it's keeping it from breaking apart or popping.
Awesome, Nerman. Great answer. Mark, what do you want to add to that?
I was gonna say because it was a cold substance, and it can't. It'll just probably if you just hold up. Try putting the balloon entirely on it. Let's see what happens.
I put it out.
That's exactly my point. It proves my point.
What's your point?
Because water puts out fire.
No, but the water's inside the
water's
balloon.
still inside.
Because it's cold still.
Okay.
George,
We're getting
add to
close
that?
here.
I wanted to add to the person before
No
them.
oxygen.
So you're putting it down there, and the heat is transferring to the water, and then the hot water is rising to the top and being replaced by cold water.
Oh, we are getting so close. Si.
Mark, is it okay if I add on to you?
Yep. Go ahead.
Okay. Adding to Mark without any oxygen, maybe since nitrogen does not react to anything, the balloon could have nitrogen inside it instead of oxygen.
Well,
Okay, well,
there'll be 78% nitrogen in here.
yeah, think about that water. Think about the water out
Can
there.
I give the hint?
Yeah.
All right. Do you remember the demo that Mr. Corbett and I did where we were heating the soil and the water, right? And one of them heated and cooled faster than the other one. Which one heated and cooled faster, the soil or the water?
Soil.
You could
Make sure you're muted.
You can't hear. There we go.
Thank you.
If soil heats and cools faster, so would air, right? Especially air compared to water because it's way less dense than water. So imagine this is like water getting heated. It takes a long time for it to heat compared to the air that was in the other balloon. There's still air in here, but there's water. And the water takes a long time to heat. And what do you want to say about that?
And when that water heats, so again, guys, water holds a lot of energy, right? Think about the ocean near the equator absorbing all the radiation from the sun, moving heat around the earth. That water in there is absorbing the heat, so it's not burning the latex the balloon is made out of. So we're taking advantage of water's high heat capacity to not pop the balloon. So I think we're ready to move on to the next one, Miss Lanigan. What do you think?
Sure.
All right, let's do it. This is starting to steam, but we're not quite there yet. Let's see how this is looking over here. I think we're getting really close over here. So I think we might be. Let's go ahead and go to the bubbles.
I love bubbles.
What do you think? Should we go to the bubbles?
Let's do bubbles.
You guys want to see some fun bubbles here?
Yes.
Yeah. Okay. All right. Let's check out the bubbles. So let me go ahead. In fact, while I'm making the bubbles, do you want to start making the snake?
Yep.
Maybe that, because I'm going to make a new solution up here.
Hopefully this is still. All right. So for all the classes, I have been making animals out of Play-Doh. So while we're doing this, I'm going to pass the time here. So you can see these other ones. The class before you, I made a giraffe, right? And yesterday I made a kitty cat and a wombat, right? And an elephant from earlier today. Whoops, there's my elephant, right? Oh, sorry, little elephant. All right, so I'm going to make another animal today. Somebody give me an idea. What should I make? What kind of animal should I make?
Snake.
Ben says a snake.
Make a water buffalo.
Mr. Corbett's class just said something too.
Snake.
Snake.
Yeah.
Joy said
Okay, you guys have to
please
raise your
stay
hand.
muted.
You have to raise your hand.
Use the hand raise button.
For Mr. Corbett's class, Joy has a suggestion.
Okay.
Joy, if you can hear me, what do you think? What do you want Miss Lanigan to make? I don't know if she can hear me.
Hey, Joy, what do you? Oh, it's because you're not. If you're muted on mine, she can't hear you. Hey, Joy, what do you want her to make?
Rabbit.
A rabbit.
That's
All
a
right.
good one. All right. Make a bunny. Oh, that's going to be. I have to make big ears. So my mom spent thousands of dollars to send me to art school. That was my first year of college. And I dropped out because I hated it. So my skills for art are not as fine-tuned as they should be because I didn't spend the time I should have in there. But I still love to do stuff like this. So
she's amazing.
Bunny's the hardest one I've had to do so far. But there's his little nose. They have big back legs. Let's do that. All right. Hard to make a little round tail. I think I got it. Okay, here's the bunny. You see the bunny? Hoppy, hoppy, hoppy. Hop, hop.
It is good.
Hop, hop, hop.
She's good, right? That's good.
All right, so there, I'm going to add that to the collection. There's our bunny. All right, and I'm going to make one more. Oh, after we do this, I'll make another one. Okay.
And let's say it again.
Put those bubbles. Oh.
What just, what? Wait, what? Let's try that again.
I'm magic. What was that?
My hand's not burning. You know what? These bubbles are weird. Why don't you try to do those bubbles?
Let me get rid of them. Woo! That was cool.
What is going on here? You know what? Let's try to go big here. Let's try to go big.
Okay.
Okay, let's try to go big, okay?
I'm going to keep working on this other animal here.
And we're going to go. We're bring this over here.
Okay.
And we're going to go real big. All right, Miss Lane, this is a big one. The biggest one yet.
Stand back, everybody. Stand back.
Here we go.
Oh!
Now, when we take these and we're making these bubbles, guys, and I put a bubble on my hand, how is it that my hand is not burning? Okay. And
cute little one.
You want to finish off those ones in there too? Awesome. So use the hand raise button. Use the hand raise button. Why is my hand not burning? What is going on?
Chloe, what do you think?
I think it might be something that's in the soap that's catching fire, but it's not on his hand.
Okay.
I mean,
all
in
right.
the bubbles.
That's good. There is something. Mark, what do you think?
I think since it doesn't have anything else to burn on.
Okay. Awesome. So here.
Post is dead. Plus, will this experiment work with any type of bubbles?
That's what we're trying to figure out.
That's what we're trying to figure out. So here, what do you think?
Can I try this?
No, these are
None
not
of
to be
these.
tried at home, like all of our demos. So here.
Come on.
So I think the reason his hand isn't burnt was because you know how like the bubbles are made out of water?
Yeah.
Like before, water puts out fire.
Yes, it does. There is some more on here. Let's hear from Miss Lanigan's class.
Sophia?
I think Mr. Corbett is a wizard.
Aha!
She thinks that I am a wizard. Well, no comment on there. I'm not able to disclose any information regarding that.
Stella?
I was gonna ask if you guys can do it anywhere other than your hand.
Sure.
Where are you thinking?
I don't know.
Stella, I just want to say I'm glad you're here because I was actually just responding to your email. I didn't realize you actually made it in. I was telling you.
Oh.
So that's not, I wasn't doing like a TikTok thing.
Josh, what about you?
I can see a lot of views on TikTok though.
What do you think, Josh? The power of science. Now, a lot of you guys had kind of mentioned this. I heard someone from Miss Lanigan's class mention this, and someone from my class that had to do with the water. Now, I put something on my hand beforehand, and I coated it in water, in a water solution that was very specific. Now, and that's why this is such a dangerous demo, because you have to have a special, just the right amount to cover, and then the water absorbs the heat on there, so my hand is not burning, which is making that the fire bubbles. Miss Lanigan, I think we're ready. I think we're ready for this one.
Okay.
Okay, Miss Lanigan, here we go.
All right.
let's try this out, okay?
Yep.
So right here we have a cold, ice cold bowl of water, and then we have some tongs. And Miss Langan, I want you to grab this. I'm gonna go ahead and move this back over here. Got everybody. Okay. So this is now got steaming. I want you to grab it with the tongs and quickly put it into the ice. Okay.
Okay. How much water was in here?
Well, there was only a little bit.
You guys remember how much you put in there?
1 teaspoon.
About a tablespoon. Okay, ready?
Oh! Crushed!
Okay, let's see.
What? Now it's full of water and it's crushed? No way.
What?
How did that happen?
What's going on?
What's going on, guys?
Oh, look at this.
What happened
It
there?
was filled up with water and it's totally crushed. What is going on?
What is happening? What do you guys think?
Oh, lots of people are raising their hand. Nervin, what do you think?
I think it's some reaction with hot going to near cold.
Okay. And then I see.
Yep. How about Ryan?
So all the atoms or molecules that were hot and cold probably mixed together and it crushed it.
Ooh, we are getting along. Ryan said the hot and cold molecules are moving around and it crushed it. We are getting closer. Let's hear from someone from Ms. Lanigan's class now, and then we'll come back to mine and hear from Bensari after that.
Ben, what do you think?
I accidentally just got my hand up.
Okay. Chloe?
Probably going from all of a sudden to hot to cold, probably crushed it.
Awesome. Bensari, what do you think? Bensari?
I think maybe like the water, the cold water and the warm water, like combined, and maybe that's what caused it to get crushed.
Ooh, you guys are so
They're
close.
on the right track.
They're on. They are under pressure.
Pressure?
What? What?
How many of you remember the demo that we did, the Friday demo, where we had the Petri dish with the birthday candle and we put the test tube over the top of it and the water got pushed up into the test tube? You remember that? Yeah?
Yeah.
Yeah, and so it's kind of the same concept. So pressure, can anybody explain the difference in pressure that would cause that?
I see Corbin. What do you think?
In the can, there was hot air, which is less dense than cold. And when you flipped it into the bowl, the air then condensed and then it shrank the bottle.
Scientific poetry.
That was awesome.
That was awesome. So he said, what was his name?
That
Corbin.
was Corbin.
Corbin says the molecules in here basically expanded, became least dense when it heated. And then the cold was less dense because it is colder and molecules are closer together. And remember, guys, wind goes from high to low, right?
High to low pressure.
Well, in this can, when it was being heated, just like air rising, right, creates a low pressure. Well, the air in here also created low pressure. And when we put it inside of the cold water, low pressure, it went streaming in there, or to the high pressure, I'm sorry. It went streaming into the low, sucking the water in, collapsing the can on itself.
So there was air that was trying to get in, just like with that test tube and the birthday candle. The air on the outside was trying to get in, but there was water in the way, so the water got pushed up into that empty space.
Okay, Miss Lady, we're going to try to fill in. We're going to try to fill up a 2-liter bottle upside down, okay, with this red ice water right here.
I'm going to make one more animal while you're doing that.
Okay, here we go.
So he's going to be taking boiling water and putting it into a plastic 2-liter bottle. Okay. And what animal should I make?
Seth.
I didn't hear it, Seth.
A dragon.
A dragon. Okay, here we go. Ready? Ta-da! It's an armless dragon. Yeah. Okay. Now, the dragon is going to put itself around a straw, really tight around this straw. It's curling up around it.
Why are you killing it?
I'm not killing it. He just likes straws.
Praise to my imagination.
This has near boiling water. I'm going to pour out right now, just so you see here.
So here is the dragon that's wrapped himself around a straw.
He's more a snake than a dragon.
They requested a dragon.
Okay, here we go. You ready, Miss Lanigan?
I'm ready.
Orca?
Okay, here we go.
Can you also make an orca?
Here we go. You're filling it up upside down. Look at that. Oh, this is awesome. Fountain in there. Filling up the water bottle. Can you get the whole bowl? Can you do it?
This is the exact same concept as the one we just witnessed.
Yep. And I don't know if you can see the water in this bowl, but the water is going away.
There we go. Now we have just filled this up. So, why did this happen? Why did this happen?
What is going on?
Pressure?
I see from Mr. Corbett's class, Bonsari.
What?
I'm sorry.
Maybe because the pressure caused it to like fill up the water, but I don't know why it's not pouring out.
Well, you can see actually the top of the straw is above the water. Right? So it's above the water, so the water isn't reaching it. If I pull the straw a little bit down into the water, and it'll come out.
There it goes.
Yeah.
Ben, what do you think?
Again, I left it up for something that I was going to say about the dragon.
Okay. Nerman, what do you think?
It's kind of like the kind of like that duck thing you did. No, not the duck. I don't know. The project, the demo you just told us about.
Yeah.
It's basically the same thing.
Exactly.
It is. We're taking example of all these things we've been learning about weather. Pressure, the heat capacity of water taking heat around the earth affecting weather, and how high and low pressure when they mix, right? That high pressure is the cold air sinking down on you. You have the weight of the atmosphere, and that warm or the rising air is low pressure because the atmosphere is lifting, and it goes from high to low pressure. And it always does that, even in these types of systems. So we can take the concepts we've been learning about weather and apply them to other things to create some pretty cool stuff. So I think are we ready for the finale? No, we're not. No. We have a trick. Right?
We have to do the trick first.
We got to do the trick first. Okay, guys, so we need everybody's cameras on for this trick. We need everyone's cameras on for this trick, okay?
You're going to all participate.
We need everyone's cameras on.
This is so fun.
It is so fun. There we go. Yeah, because I'm gonna need to see you guys. I'm gonna need to see the fingers that you're holding up. Now this is a fun carnival game. And Miss Lanigan, can you join them over there?
Yes, I will come over here. I love this one.
So let me get some.
I'm really good at this game, so I'm gonna let all of you, help me out here because
I've got some water.
It's tricky.
And if you guys remember the carnival game, right, where you move the cups around and you got to guess what it's in, which one it is in.
Usually they're upside down.
Yeah, we're going to go with water. We're going to keep it upside down because at the end of this, we're going to test it by dumping it over Miss Lanigan's head. What's that?
That cup's different than the others. So it's going to be, I need one that's the same.
Oh.
We don't want to give it away.
Oh, no.
They all need to be the same.
Okay. Where did I put my other cups? This one will work. Okay, here we go. All right, so empty, right? We got no water in these cups. Here we go. They're all empty. So I'm going to go ahead and pour the water in this cup. Okay, so here we go. There it is. Water is in. So water starts here. So watch carefully. Okay, watch carefully. I'm moving up here a little bit. Okay, ready? I'm going to start easy. Give you guys a break here. I'm going to go slow. Start off easy. What's that over there? Okay, what is it in? Is it in cup 1, 2, or 3? Hold up.
Show us your fingers.
Hold up your fingers. 1, 2, or 3.
Lots of ones.
We see. So
lots of ones.
Most people are saying 1. So let's see if you're right. Here's cup 1, and let's see.
Good job.
You are right.
Good job.
Okay, so it is in cup number 2. All right, so here's the water starting. And I'm going to go ahead and move these around again. All right, I'm going to go a little faster this time. Is it in cup? 1, 2, or 3?
1.
What? These guys are good, Miss Flanagan. All right, here we go. Okay, let's see. It is in cup number 1. All right, so I'm going to go faster this time. I'm really going to challenge you here, okay?
Where is it now?
Here we go. So the water's starting here. Now watch carefully. 1, 2, or 3?
3.
What? Look at everybody.
Okay.
Thinks it's
That's it. So here's 3. Let's see if it's in there. Okay, now here goes. I'm gonna go as fast as I can.
This is where I get confused.
This is as fast as I can, and then we're gonna pour them over Miss Lanigan's head, and we're gonna put her trust in all of you guys to the test.
You have to guess it right. Which one is it in?
It's in this one.
So it's in that one.
Here we go.
Go. Oh no.
No. It's okay. It's okay. Here we go.
Oh, wow.
Here we go. Which cup is it in? Okay, Miss Lanigan, come on over.
Lots of 2s.
Come on over.
2.
It's all right. We're just gonna roll with it. All right. So here we go. You guys say 2. So that means it's not in cup 1, right? Not in cup 1. Okay. Not in cup 3. She's lucky. Here we go. Cup 2. Wait a minute.
It's because you spilled stuff.
It's because you dropped the cup.
You dropped the cup and it's all spilled out.
Use your virtual hand.
They said that I dropped the cup. Okay, so let's try it one more time.
Let's do it one more time.
Okay. All right. So here, let me get some new cups on here because that one was a faulty cup. And make sure that we can get that going here. Okay.
Hang on, we're gonna get some brand new cups and try it again.
Okay.
Because it did get a little wobbly that time.
Yeah, and
It's okay.
that one also has now is all wet from where it spilled. So let's try this one more time.
Let's here.
See
Let's
how you
make
guys
sure. Yeah, there's nothing on here. There's some soap.
Okay.
Okay. Make sure everything's dry.
Okay. Are we ready?
I think so. Oh, here, let me get you some water.
Okay. Here. And
Okay.
you grab some of that. Okay.
Can I watch from here this time?
Okay. All right, here we go. And okay, we got water.
Got water?
Okay, got water. And we got the cups. Okay, they're all the same. Okay, no water. No water. No water. No water. Okay, no water. Okay, here we go. Let's try this one more time. All right, I'm going to step it up though to the difficulty level after the first one. Okay, so we'll do one more warm up. So we'll put the water in here. All right, so here we go. So water's here. One, 2, or 3? 2. 2? Okay, here we go.
2.
Goes in 2. Okay, we'll do one more here. Okay, so water's right here. One, 2, or 3?
2.
Again, these guys are good. Okay, it's in 2. Okay, so put it back there and in here. All right, here we go. Water's here. Ready? I'm gonna go super fast now.
Dizzying. Oh.
1, 2, or 3?
1.
1.
Okay, here we go.
1.
Here we go. 1. So let's start with 3.
I'm trusting them. I'm just going to stand here.
So here goes 2. And here goes 3.
What?
Where'd it go? You have to wait till second semester to find out.
We're going to do a lab second semester, and you will remind you of this.
Don't trust.
You will be reminded of this thing.
Yep, you got
Why?
Don't
get
There are a couple of the demos that we've done for the Friday demos that also haven't been answered. So we've had you guessing like Bernoulli, those principles. We haven't answered that yet. So there are some things coming up that we're going to be giving you the answers to.
Now the grand finale, guys. This is what you all have been waiting for. This is the fire tornado. Now, in order to do the fire tornado without setting the smoke alarm off, I'm going to go ahead and add some water to these sponges first, because as we know, water holds a lot of heat, right? And it creates a buffer. So this is going to limit the amount of smoke that's produced, because as soon as the sponge starts burning, we're going to have a lot of smoke. So if the water can kind of shield it, we can then just have the lighter fluid going. So
we did have all of Mr. Corbett's smoke detectors going off earlier today.
Yeah, we don't want to do that again. Too long.
It's so much fun though.
I heard about that from a friend.
It was fun.
And we wipe that off.
Except that Mr. Corbett's wife was teaching his her first grade class at that time, so they had to listen to that.
No.
Okay, Miss Lanigan.
Okay.
Let her go.
What is this, by the way? There's sponge.
Sponge, and it's a crucible. And a crucible is used for all kinds of things, but we're using it today because it provides a flame-resistant thing. And now what you guys see here is a grate, and as this fire grows, we're going to see our fire tornado get bigger and bigger. Now, this grate is very important because the grate is taking the air and it is moving it around. And if we think of what we needed for tornadoes or hurricanes, and as this goes, it's going to start getting bigger and bigger as that water kind of evaporates off and gets going. We'll have it hopefully coming out of the grate here. But you can see now that as it spins, it's having an updraft, creating a circular motion in the fire, which is in turn creating our fire tornado on there. Which is, let's get it going here. Woo! There we go. Now we're starting. It's starting. Oh, that was a good one. Here we go. Here we go.
Remember, those updrafts are caused by the cool air rushing in and pushing up because of the heat. And,
there it is.
Awesome.
The fire tornado.
I think we need to go out. I think we need to let it out.
Okay.
We turn the fan on. Quick.
The bull. Fan. Go. All right. We'll see here if we are interrupted by my fire alarm again. I think we'll be okay.
I think it's good. I just saw the smoke coming, and I just go.
We get a little excited when that goes here inside, and as soon as that black smoke starts to come, the sponge is starting to burn. So we got to get that fan rolling in here. So
I think we did good. I don't hear anything yet.
We're good so far.
Woo!
So guys, and again, when we think about tornadoes, we got to have heat rising, right? So we have to have intense heat rising. We have to have a circular spin of those, and then that updraft, which is what we recreated with that tornado.
Fire tornadoes do happen in nature. They really do happen. And fire, when there's like a wildfire, they happen in wildfires. And volcanoes, when there's a lot of heat from a volcano erupting, it can make its own weather system.
Pretty awesome.
Really cool.
So guys, that concludes our extravaganza. I think we're going to go into different spots now to end our classes on here.
Yes, and we won't see you until next year. Friday, tomorrow you have class, but all of you do not have to come, so I'll let Mr. Corbett tell his class, I'll tell mine.
Here we go, guys.
Don't forget we have school tomorrow.
Moving over here.
I'm going to go turn off the fan and then talk to you.